So it's recording now. So if you are on assignments, and I'm really just double checking also that I did what I intended to do. So homework for Friday. What you'll see is the test is on arc length, area of a sector. That would be S equals r theta, 1/2 r squared theta. Linear and angular velocity. Applications where you're finding out like how tall a building is or something, okay? Inverse trig functions like that first little worksheet I gave you, like arc sine of -1/2. So all of these are from when they were getting ready to come over. But anyway, back to this. Composite trig functions, that means that I put a trig function inside of a inverse trig function or vice versa. Okay, like we worked on maybe the last class some. And identities, which you just will have done over, for today, and then we'll work a lot of them in class today. What you should study is the homeworks from page 262 and 322. You should have if you didn't have a record of that, I think you know how to check previous on our calendar view, one of those two. You can go back and see what numbers I assigned on those pages, because those are always carefully selected. You can check the answers to the odds in the back, but you could probably find the answers to everything on Slader, the super secret cheaty place. All right, worksheets on linear velocity, inverse trig functions, composite inverse trig functions. And also I showed you and some other people, there's lots of that interactive practice. You can practice inverse trig, you can practice trig. I've had a conversation with a couple of people about, like, this is where you should be now. When you see arc sine 1/2, your brain should think 30 degrees or pi over 6. I know that you probably will still draw your chart on your test, but the next topics aren't, in fact, even inverse trig doesn't work very well if you're not really good at that. There comes a time that you need to leave your little multiplication table, 6 times 3, and you're following down until you get to the little square that says 18, okay? So that's a memo page. Your little chart is very small. It's not anything like your big multiplication chart that you studied. So you should have done it over and over again to where you're pretty fast at it. If you feel like that you want some more practice on that so that your test goes more smoothly, you can go to that interactive practice problems under topics, and you can turn on sine, cosine, and tangent, and then do it in degrees and radians. If you have a question about that, just see me or email me. You could turn those off and practice inverse trig, okay? I would suggest practicing sine, cosine, tangent, inverse sine, inverse cosine, and inverse tangent, because if you can do those, you can handle the reciprocals. That way you're just looking to see if you're fast at it. Question?
Is there like a memo quiz in the beginning where we can have our calculator?
No, I don't know that we've even used our calculator on this. Well, you'll need it for linear velocity. So what would happen though is I'm not about to let you have it for questions like arc cosine of the cosine of 240. You can just punch that in your calculator and get the answer. So you will have my first page will be without a calculator, but you'll only probably want it for linear velocity problems. And also you will not have your calculator while you're working identities. And a lot of y'all realize you were just writing down words, but some people will program all their identities into their calculator and then they'll look at that. So you've got to know all of your identities. And as time goes on, you know that I think you can tell I'm a very reasonable, not stick in the mud kind of person, but you got to know this stuff or you're not going to be good at the next topic and the next topic and the next topic. And so you will not have your calculator. You'll only have your calculator I can think of for the linear velocity and area of a sector. Okay? So anyway, ironically, what I know is if you're dependent on some program where you've typed them all in, two things probably happened during that time. One, that you memorized them while you were having the pain of typing those in, unless you can find them online if you know how to download them into your calculator. I wouldn't suggest you spend any time doing that since you won't have it during that. Also, what they know in the SAT and the ACT is why they let you have your calculator so much is if you're a student that doesn't really know your stuff and you're having to comb through lots of menus on your calculator looking for things, you're probably not going to do well on it anyway. So anyway, that beside that. So good question, Danielle. So here's some more practice linear velocity problems in addition to the worksheets and stuff I've given you out of the book. And I don't want to do that now. I'm going to open them all and see if I've actually loaded the right thing on there. So some of this that I've posted you've not done, so it'll be like new practice, okay? Also, I'm going to give everyone a blank copy of one that's posted up here if y'all will pass this around. It's only one page, so it's not going to be as confusing as the last time I passed something around. And hopefully this will open and, okay. So here's some linear and angular velocity questions. And then the answers. Whoa, that wasn't mine. Okay, so this is what the linear and angular velocity, and then you see down here are the answers. Okay, so you can practice those and check your answers. Always give me 3 decimal places. That gets you ready for AP Calculus A, B, or BC. Give 3 decimal places. Okay. All right, so there's some more practice. I would say that you could do a grade on the test, though, if you just practice that page with 4 problems on it. That's what I'm going to be looking at when I make out the test, okay? So at the most, what I would give you is, as far as like an application problem, would be a hoist, which we'll work in a minute, a pulley, and you'll definitely have a bicycle problem, where I say you're going, I'll change the miles per hour, you find the RPM, or vice versa. So if you can do the 3 that I've done in class a few times, and I think I've tried to make those pretty easy to find under the topics component, okay? One thing that came up this morning, don't just go straight to my YouTube channel. You won't be able to find what you want there. You'll find a lot of things you don't want, like my son's 2nd birthday party. But if you go to topics, you can then look and see what you need, what date you want to look at, okay? You ought to be able to narrow it down by the homework. So there's that if you want it. If you only want to study the worksheet you have with the bicycle on it and the problems from page 267, you'd be fine, okay? But it's there if you want it. Okay, so then I've given you, I don't know what this is. Oh, I think that's just a blank linear velocity in case you wanted to practice again. And again, if you could do these, you could do you'd be able to do whatever I ask you, okay? Pedal sprockets 5, I'm making sure I gave you the corrected copy. Remember the first one I gave you had 2 both times, and I think this is right. You have a bigger pedal sprocket of 5 inches, a radius of 2 inches, and the wheel is 14 inches. You might have some, and you kind of want, like from page, I think 267, where you did homework one night, just the area of a sector, and you go 1/2 r squared theta. You just sort of find the area, like finding the area of a triangle, but you can find the area of a sector. Okay? So again, practice those problems, but I think you'll be okay. You should only use s equals arc theta and 1/2 r squared theta if you're in what? If you're going to be studying in radians. Don't put 120 degrees in there. Instead, put it in pi. All right, so I gave you a blank one of these, and you should have the answers to all of that. If you don't, I've got the solutions I could send you. All right, practice inverse trig is what you just got. I had a lot of people asking me for more of this, and we'll work these problems together in just a minute, okay? You will have the answers like this written on your sheet in just a minute. Some of you, for practice purposes, may not want to write the answers on your sheet. You'll know where they are in the video. You can fast forward and check your answers if you want to like do it again. Or you can write them on the back if you want to kind of test yourself for later. Or you can write them on the front, just whatever your study skills are. Suppose that you wanted to practice some more. It'd be easy enough for you to do like arc tan sine of pi over 3. You could change it up and test it on your calculator. I just don't know if you know how to decide what is happening on your calculator, because it won't return pi over negative pi over 6 to you, but you can figure it out with decimals. But anyway, I've given you a lot of practice out of the book and then giving you some more composite functions with trig, inverse trig. Remember inverse trig functions, their domain is so much smaller than a trig function. Sine's domain is all real numbers. What is sine's range? Negative 1 to 1. Cosine's domain is all real numbers. Cosine's domain is negative 1 to 1. Tangent's domain is not all real numbers. Why not?
Because it has an asymptote.
It has asymptotes. It's undefined. Every pi radians you hit an asymptote, okay? Or every 180 degrees. And what is the range of tangent?
It's
Negative infinity to positive infinity, okay? Because it goes up forever and down forever. It's not contained like sine and cosine. Remember, sine and cosine are the only two graphs that have true amplitude. Now the inverse trig functions are super duper limited, okay? And I'll write all that down in just a minute. So let's keep looking at what is here for you. Inverse trig, I think this was the first worksheet I gave you that you should have the answers to. Okay? Oh, well, the answers are there, so never mind. Let's make that bigger. I guess that's just as well. Let me see if I agree with all those answers. I didn't know I had this in my computer. Oh, these little missing things, a lot of times it may even be compatible on your computer. I think it's something with this computer. Did y'all see that thing come up a little while ago I didn't update on? But those would be ties. I don't know what that is, but you've got a copy of it, okay? Hopefully it'll come up on your computer. If somebody has theirs open to my topics page, you may want to check it and see. But, just let me know and I can repost something else. These are the solutions to some identities on your packet. So this is just how I worked them out. You don't have to work them this way. We'll talk about that. I'll read what you write. And then some more identity solutions from your packet. So you have a wealth of solutions in my handwriting, hopefully. There's the questions, and hopefully the answers are following there, okay? And I don't know what that is. Trig identity quiz, that's not mine. So I don't know what that is. Is that my handwriting? That's not even my handwriting, is it? This may be Mr. Hill's handwriting.
Yeah, it kind of seems boyish. Yeah.
All right, really bad. I'm just looking to see if
You wouldn't do those arrows. Yeah. Those arrows are very.
I may have gotten it from wherever I got the worksheet. I didn't make out the worksheet, so maybe the teacher, and they probably also gave a quiz to their students. I don't know who this person is. Okay, so in a little while on your packet, there'll be a couple of things I would not be able to ask you and looking through this that you just don't know. Well, no, I think you know all of this. Anyway, we'll do some of these together. All right, so there you have a wealth of information to study. There's really not any great delta math on this right now, so that's why I gave you all these solutions. All right, so let's start with the sheet that you have in your hand and just kind of move through review, and then we'll hit identities really hard. All right, so there's like a cute pic of them, but I've also got it sized so I can write. Number 1, cosine of the arc cosine of 5. That's undefined, no solution or whatever you want to say, okay? You should not go looking for an arc cosine of 5. Is there any way that you could find an angle that gave you a cosine of a 5-to-1 ratio?
No.
Cosine is x over r, or adjacent over hypotenuse. Is that possible for it to come out to be something more than 1?
No.
Are y'all okay with that? If you punch that in your calculator to check it, it would just say undefined. or error or whatever it says, okay? All right, but number 2, cosine of the, Mr. Hill, by the way, calls those garbage questions, okay? So if I ask you something like arc or inverse sine of 240 degrees, or, I wouldn't write both of those. I'm not even sure what that means myself. Okay, so inverse sine of 3/2. Both of those are garbage questions, okay? I can use this language. Why is that garbage? That's what arc sine is for. Okay, when do I use arc sine? Is when I'm looking for an angle. You see that doesn't make any sense? I should say sine of 240, not arc sine of 240, okay? And this one's also garbage because sine can't be 1.5, can it? Highest thing you've seen is sine at 90 is 1. All right, so let's pause for a minute and talk about the domain and range of sine, cosine, and tangent. Because I was talking about it, and this is not new. Don't panic and go, oh my gosh, okay? Your last test was on graphing. And so the domain of sine and cosine is all real numbers. I was going to do negative infinity to positive infinity, but I'll just do all reals. The domain of tangent, we'll get into next class how you would actually say it, but you know it's not all real numbers. It has some asymptotes in it. Every time you hit a pi over 2, 3 pi over 2. Yeah. Every time you hit one of the, I can't write, I'm sorry. Pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, x cannot equal those. I haven't really told you how to write that yet, so I won't be asking that. But do y'all think about your tangent graph? It went from negative pi over 2 to pi over 2, and it went like this. And then every time you hit a pi over 2 or negative pi over 2, it's going to be undefined. Okay? The domain, that's the domain. The range of sine and cosine is your y values are going to be between -1 and 1. That's for sine and cosine. For tangent, it's all reals. And I'm just going to draw a picture. What's the domain of arc sine and arc tangent? You're only allowed to look where? Quadrants 1 and 4. How are you allowed to get into quadrant 4? You can go from -90 to +90. That's your choice. Okay? Those are your only choices. You can't get into the 4th quadrant by going all the way around. You've got to either go up or down to get to that. You can go to this neighbor's house or this neighbor's house. That's it. Okay? And so really the domain of these is negative pi over 2. Sorry, that's not the domain. The range, the answers to these would be from negative pi over 2 to positive pi over 2. You're looking for an angle. What about domain of arc sine and arc cosine? -1 to 1. X has got to be between -1 and 1, but what about tangent? All reals.
I think that's what I meant when I said all real numbers earlier. I meant inverse.
So this is what Zaina has noticed. If you take an inverse function, shouldn't their domains and ranges switch? Because your output and inputs are switching, okay? And so where your y's could be between -1 and 1, now the x's have to be between -1 and 1. And where your answers could be all reals, here your input could be all reals. We had a problem since it wasn't 1 to 1. We've got to be really careful with our range. Our domain was all reals. Our range can't be all reals because then we'd have to sit there and, if I say arc sine of 1/2 and you think you're going to list every time that happens, you won't finish your test. You'll spend the rest of your life on that problem. Because how many answers are there to sine of x equals 1/2? It hits it over and over again, okay? I want you to understand, I'm going to stop this because now it may be scaring you for me to list it all up here. I still wanted to talk about it for understanding, okay? Mr. Hill's students might have to actually report the domain and the range. I want to make sure you understand what you're doing when you work the problem. I don't ask as many definitions and things like that. For you, I target more your your understanding of I was looking this way and now I'm looking this way. We've done it over and over again with our graphs, okay? Elena?
Wait, so for cosine?
Oh, for cosine, the range is 0 to pi. That is important to do that.
And the domain is all real? Not
No.
cosine.
For arc cosine and arc sine, the domain is -1 to 1.
And then for tangent,
It's all reals. So I can't say find arc sine of 4. That's garbage. But I could say find arc tan of 4. I don't know what it is, but you could punch it in your calculator and find it. Okay? All right, so let's clarify what we need to go on. Arc sine and arc tangent are both odd functions, by the way. We'll get into that later. But you're able to go into quadrants 1 and 4. That means you can go from -90 through 0 to +90. Those are your only choices. For arc cosine, you can be in quadrants 1 and 2, so you can go from 0 to 180. Sorry, that green does show up as well for you as it does for me up here. Now, just like when you see a square root, you have to adhere to the rules of the inverse function. I know I can square 5 and -5 to get 25, but when I put you on the square root function, you're very limited and you only answer 5. So when I ask you an arc cosine or an arc sine function, and you can practice it by typing it in your calculator, you've got to stay within the domain of the function that's asked of you. So now let's go back to your worksheet. All right, so I am on number 2. All right, so number 2, I have the cosine of the arctan of 5. Back to Danielle's question, if I don't let you have your calculator, well, by the way, if we think of a tangent graph, it could hit 5. There's an angle that gives that. I don't know what it is. But we've done this before. Again, this is not new. If we don't have our calculators, we'll draw a little triangle. You may not even be in the first quadrant. However, I know I am. How do I know I'm in the first quadrant right now? Arctan can be in quadrants 1 or 4, so I'm definitely in quadrant 1 right now. All right, arctangent is an opposite over adjacent. And I'm going to find the hypotenuse. And even though I never even found this angle, I can find the cosine of it. What's the cosine of this angle? 1 over root 26. Don't do it now because we need to do more review on identities. But it's interesting to type this into your calculator, even in degrees. You could go arctan of 5 and you could actually find the angle. I drew this horribly. Notice my 1 to 5 is not drawn very well. I bet the angle's close to 90 degrees. Because if I go out only 1 and up as far as 5, that would make my angle pretty big in the 80s. So you could find that angle and then take the cosine of that angle and you would get this number. Okay?
So it's not like cosine 1 over root 26, it's cosine of something.
Here, this forces you to find an angle, and you wanted the cosine of that angle, okay? All right, so now what happens on number 3? Sine arc cosine of 2x. Same thing. I'm going to go up here. I do not actually know if this is positive or negative. But we talked about the other day, it doesn't matter. I may talk about it a little bit. But you can draw it the first quadrant. Cosine is opposite over hypotenuse.
It's adjacent.
It's not that. It's x over r. It's adjacent over hypotenuse. Sorry about that. X over r, I should stay with that. So I'm looking for y. Now where could arc cosine be as we're looking for an angle? Couldn't it be in the first or second quadrant? Okay. But either way, when I go to find sine, y over r, it's positive. Do you see I don't have a dilemma? Okay. So I should address all of that. All right, now I'll do the Pythagorean theorem. Are y'all okay if I just slap this on here? I don't know if you're okay with that. No. Okay. So I'm going to say x squared plus y squared equals r squared. So I get 4x squared plus y squared equals 1. So y squared is 1 minus 4x squared.
Oh,
Hopefully you understand the square root situation more, why you say plus or minus. Remember I said that indicates one day you would choose. I know what I'm doing now. I know I'm looking for the plus one. The square root of 1 minus 4x squared. So what's the sign of this? Y over r, opposite over hypotenuse. So there's a couple where you might have to draw a triangle. If you don't know the value, rest assured you could draw the triangle and figure it out. Okay? All right, now let's move on to some that are more straightforward. All right, so number 4, arctan of the sine of pi over 2. I'm going to say I'm going to work the rest of these really fast because I want you to be able to process them yourself, okay? I'm going to work them really fast and I'm not going to slow down. If you need to meet with me after you think about them, please send me an email and let me know, okay? The sine of pi over 2 is 1. Arctan of 1 would be pi over 4. If I have arc cosine of the cosine of 240, we're learning more about inverse functions. They don't necessarily just cross each other out. There's a problem to be worked out. I would say just always work out the problem. The cosine of 240 is negative 1/2. Okay? When I go looking for an angle in the appropriate quadrants that gives me negative 1/2, I'm going to have to go over here. Does that make sense? To 120. Arc sine of the sine of 5 pi over 4. The sine of 5 pi over 4 is negative root 2 over 2. And when I go looking for an angle that gives me negative root 2 over 2, I'll find it down here. It would be negative pi over 4. Number 7, sine is on the outside now and arc sine is on the inside. A different composite function that you've got to work from the inside out. The answer to that is going to be 1/2, but let's stop and work out the problem. Arc sine of 1/2 is 30 degrees. And then what's the sine of 30 degrees? It returns me to 1/2. Just a second, Zana. And then number 8, tan of arc cosine of 1/3. If I don't let you have your calculator, you don't know that, so guess what you're going to draw? A triangle. Arc cosine is positive, so this is 1 and 3. If you do the Pythagorean theorem, you get square root of 8 over here, which is 2 root 2. You can do that yourself later. Now can you find the tangent of this angle that we don't even know? I can go opposite over adjacent, or y over x. What would the answer to this be? Undefined. That's a garbage question. I'm afraid some people would go, oh, it's the cosine of the inverse cosine is just 4, but the arc cosine of 4 doesn't even exist. So just be on your toes. You're in honors. Okay? Zaina?
My question is that when the inverse portion is on the inside of the parentheses and then like the regular one is on the outside, do they, like even though you should work it out, do they always cancel each other?
No, I just did one that didn't.
Oh, sorry.
But as long as it's a viable question, that is so insightful, Zaina. That's
But
great.
like, I mean if it's the
As
same,
long as it's, well, I just did one that was, I just erased it for some reason. Like, so be careful because you've realized something really important. The answer to this one is undefined or no solution. So they don't just cancel each other out if the original function's on the outside, okay? But do you see why, Zaina? Because this isn't even a viable solution on the inside. Do you see what I mean? However, you've noticed something real important. I think all of us are a little more relaxed if we're squaring than if we're square rooting. You know, we're a little more relaxed if we're cubing instead of cube rooting. I'm a little more relaxed if I'm adding instead of subtracting. Okay? So you realize something really big there. When you get to this part, it is not near as tricky if the sign is outside the other one. But I would always strongly encourage you just to work it out. You can suspect that's going to happen, please work it out.
Like for the one that you did at the very end, the reason why it's undefined is because the thing on the inside doesn't have a solution.
Exactly.
But if it does have a solution, can you safely assume, or should you?
I would safely assume it, and then on the test I'd work it out. Yeah. Good. I'm glad you noticed that. Chloe.
For number 5, I understand why I understand that it's a person in the third quadrant, but a cosine can't be in the third quadrant. But
Right.
how would you? And I understand it's supposed to be in the second quadrant, but how would you know that angle is 120?
The 60-degree reference angle. Or I'm looking for arc cosine of 1/2. For ratio of 1/2, I'm going to have a 60-degree reference angle. In the first quadrant or the second quadrant, since it's negative, I've got to go into the second. So this is what happens in real life when people are having to work these. This is a problem to be worked out. A really good math student doesn't really put a whole lot of weight once you get a better understanding of how inverse functions are theory. So it's best just to work it out like Xavier and I were talking about. So that actually just has an answer, negative 1/2. And then your calculator goes looking for something, and it's going to go, well, I didn't find it in the first quadrant, and it'll find a angle that gives you that in the second quadrant. But your reference angle is really important. Okay? Mary Elizabeth?
Do we have to do it that fast?
You should be getting there, but I think on your test you wouldn't be as fast as I said I'm going to go fast
Okay.
to get your answers out there so we can move on. So by next year you should be that fast. During this year we should get there, okay?
So for the ones that you did at the end that it looks like it cancels out, if it's if tan is the one that looks like it's canceled out and the inner one is undefined, couldn't it still have an answer because tan has undefined?
It wouldn't in this case. If it's an arctan of a tan, is that what you're talking about?
I think so.
That would always work.
Okay.
But if it's an arctan of a cosine, that could fall apart.
Yeah.
Okay? All right, so now let's look at the next picture. All right, and here we go. All right, so put that aside and get out your homework. All right, I'm going to do a couple of them, and I just want to knock out a bunch of identities. Girls, the rules are, and the rules are not going to change, and they will not be discussed because you know me well enough to know that I haven't, and some of you had me before in another class. You know I'm not the kind that will do it my way because my teacher said so, and I, tutor people like that sometimes, and I'm like, oh, that's not the best way, but we got to do it, their way. I'm not that person. And there's not one set way to do these, but there are rules that you have to adhere to. It's like if you got out, we went and got a jigsaw puzzle, and we dumped it all on the table, and we started trying to put it together. I am able to put it together as long as I haven't lost a piece, right? That's the fun of the jigsaw puzzle. You have all the pieces. It will make the picture on the box. But don't we kind of keep an eye on the picture on the box to try to do a job? You've all done a jigsaw puzzle. As long as you haven't lost a piece, you're trying to get that picture. I don't think you can put all those pieces together if it was a barn and make a river. Do y'all see what I mean? So what's happening right now is you don't know what you should be making. So I have to tell you what's on the cover of the box. That's what the right-hand side is. You are not allowed to add something to both sides. You are not allowed to mess with the right-hand side. You are trying to morph the left hand into the right hand. The pre-cal teachers or tutors that don't adhere to that are wrong. Okay? The whole purpose of identities, and some of y'all worked with me this morning and actually realized what's going on. I'm just giving you the picture on the box. I'm going to go in and second, in the next unit we go to, and all the way through calculus and engineering and physics, if you can't change it into this expression, you're stuck. You're almost done. Okay? So right now I'm telling you what it should morph into. Later on, I'm not going to tell you. You just got to morph it into something yourself. Okay? So you are not allowed to mess with the right-hand side. Another reason is, how ludicrous is that? If somebody tells you that two things are equal, then hello, if you add something to both sides, it should still be equal. I'm not asking equality. I'm asking you to change it into something. Do y'all some people really like adamant about this, okay? But I get all kind of, my tutor says I can add cosine squared to both sides. No, you can't. They're wrong. That's not the purpose of identities. Okay? All right, so hopefully you got number 1. You've got to show me every step. I might as well do number 1. It's so short. What did you change secant into? 1 over cosine. The rules are, so did you change it into what I told you to? Okay? Number 2 is sine x times secant x. What did you change secant into? 1 over cosine. And then you have sine over cosine, which is tangent. Now, let's go to Mary's question. How fast should you be at these? Okay? I don't care how fast you are at them. I don't care how good you are. I watched this morning, Michaela, on a long when we were working on that back board, she was starting, it was starting to grow on her, and she was starting to see ahead. Like, you will look at this soon, if not today, and realize that that's tangent. Because your brain is so smart, you think, oh, secant's 1 over cosine. I've got sine over cosine, I've got tangent. If you go straight from here to here, no credit. Because I already told you what I'm looking for, and I told a few students this morning, it's kind of funny to grade these, especially the longer ones, because people work along, and then they're like, tangent squared. I'm like, where'd that come from? I mean, they'll just, hope I don't notice, I'll notice, okay? So you've got to make sure you show me every single step. You're proving to me that you can do it, okay? I'm going to keep moving, Lindsay, for now. Don't forget your question. Number 3, I made cosecant 1 over sine, and I made secant 1 over cosine. And then some of y'all go keep, change, flip, or whatever. So I'm going to say 1 over sine times cosine over 1. And what's cosine over sine is cotangent, okay? Let me pause for a minute. Around the board over there in physics, some girls that were working physics problems, you see an integral symbol. I always try to not write sex when I'm writing secant x, but it just happened. Secant x. Okay, so anyway, next year, you're going to have this. I taught AP Calculus BC for longer than you've been alive, okay? Seriously. That's pretty scary, maybe. All right, so anyway. That's so horrible. I can't do that problem, okay? I mean, and you may think, well, you're just a high school teacher. You could take this to any professor at any university, and they can't work that problem. There's not, like Anna was over there working, she goes, are we going to learn an anti-pollution, anti-product? Well, I know that didn't mean anything to you. We can't work that problem. We've got to change it into something that we know. Well, guess what? If I know I can change this into cotangent, they've memorized the integral of cotangent. They know the answer. So do you see why right now I'm giving you what you've got to change it into one day? You've got to get there, okay? All right, now let's do the next one. And there's going to be more than one way to work a problem. And so I'm not saying please don't come to the test and work it 2 different ways, okay? I don't care if you take the long way or the short way. Sometimes you just have to go with your brain power. I'm trying to turn this into sine squared. I'm not even going to write down the right-hand side. I'm just trying to get there, okay? Also, something Brianna and I talked about this morning, I think it was me and her, that, like if we're doing a jigsaw puzzle or a crossword puzzle, or even one of those puzzles, if anybody ever done one where you have the word bank, but I might say a 5-letter color, and it starts with a B by everything else you filled in, so you might put in black. But then as you fill in more things, you might realize, oh, it needs to be brown. Do y'all see what I mean? Okay. So you could actually go the wrong way on an identity sometimes, so you'll know pretty quickly it's not happening for you, and just abandon it and do something else. That can happen, okay? One thought here is to distribute. That works great. I mean, there's so many different options here. I'm going to go when I start to see squareds, my brain thinks of the Pythagorean identities. I have on my sheet of paper, tangent squared plus 1 equals secant squared. If I tell you 2 plus 3 equals 5, I feel like that I've also taught you that 5 minus 3 equals 2. Do you see that statement enables you to change that up a bit? Okay? So I'm going to change, what is secant squared minus 1? So this is cosine squared times tangent squared. Oh, yeah. And then there are people in this room that realize they're done. They're like, oh, I got it. It's sine squared. If you do that, you won't get credit. Because I can't tell if you know what you're doing, or if you're the kid that's trying to slip the magic answer in and go, like, some people get right here and they're totally stuck. Right, I don't know what to do, so I'm sine squared and you won't notice, okay? You've got to show me what you're doing. So what are we going to change tangent into? And it's squared. Now I have it, okay? I bet somebody did number 4 a different way. Let's do it in black, all right? Did anybody distribute? Okay? So cosine squared. Some people probably change secant into 1 over cosine. And then if you distribute, you get 1 minus cosine squared. On your memo page, you have this statement, and you've got to have this memorized by Friday, your new identities. What is 1 minus cosine squared?
Sine squared.
Those people also got it. It'll take me a while to grade your papers because I'll have to grade what you write, okay, and see if you got there. I don't care if yours is 7 steps and your friend's is 3 steps. If you both got there, full credit. I'll probably write a little note off to the side. This would have been easier just to still guide you through it. All right? Lindsay, let me pause. Do you remember what your question was?
Yeah, so when you're working through these, and so like you just knew that like secant x squared x minus 1 equals tan squared x, like from your memo page, like we would have that memorized obviously. So like, but you can just write that, like you can just write tan squared x there without, do we need to like write out like
No.
what we have on, do you know what I
The
mean?
only reason you'd be writing that is if you know what you're doing. Nobody's just going to write tangent squared out of the blue. If you see secant squared minus 1 and you know it's tangent squared, I know you know what you're doing.
Okay, so that's
Okay? Good question.
Well,
You can. I'm modeling what I want y'all to do.
okay.
Okay? If you do more, that's fine too.
could you also just replace like
Oh.
only the secant squared x, and then like leave the negative 1 there, and then say that secant squared x is tan squared x plus 1, so then it'd be tan squared x plus
Yes.
1 minus 1, and then cosine times
Yeah,
tan.
I would say in the future we probably look at the body of it from our Pythagorean identities, but that I see what you're saying. That would work too, because then something canceled later from the cosine squared. Yeah, that's fine. One like that comes up on something else later today. Okay. Also, don't forget the power of email and screenshots and stuff, or pictures that you take of your work. If you're studying and you're at home, great. You know, who was it I met with yesterday? Oh, Isabel will tell you that I might still be here when you get ready to work at 6 o'clock at night. But anyway, if you email me and go, "Is this okay?" I can look at it and let you know. You don't have to like wait. Okay, you just have to wait for me to check my email. But I check it a lot. All right, let's go to number 5. Number 5 is tangent x plus cotangent x times tangent x. And I've got to turn that into secant squared x. All right, and I'm going to use, I'm going to go back to number 4 for something that a couple of people know about in just a minute. One way to work this, I'd say the longest way to work this is change everything to sine over cosine, okay? Danielle and I did that this morning. We changed everything to sine over cosine, sine x over cosine x, plus cosine x over sine x. And as long as we're at it, we might as well make this sine over cosine. If you're super stuck, sometimes that's the way to go because you're so familiar with those words. Now remember I said that you're coming off your memo page with a little bit of algebra. Like follow your instincts. It's almost like you're tripping over yourself. You can't help but it says to add those two fractions together. And so Danielle and I got a common denominator on the inside. Sometimes you have to get a common denominator. Okay? My common denominator is sine x cosine x. And girls, if when you're working these, you feel like you don't know where you're going, welcome to real life. Research, trial and error with great intelligence. So it's maybe the first time you've had this feeling where you're writing down things, but think about all the different things that are happening in the world right now where people with a lot of great information are trying to make something happen. What do you have to multiply this by to get that common denominator? Sine. So would that be sine squared? What do you have to multiply this by? Cosine. What's sine squared plus cosine squared? 1. Sine squared plus cosine squared? Sine x, cosine x. And now what can I do? Cross out the sine, and what's 1 over cosine squared? What's 1 over cosine? So that would be secant squared. Girls, let me pause for a minute. If I have 1 over sine cubed, I can call that cosecant cubed. But if I have sine cubed plus cosine cubed, that does not equal 1. If I have sine plus cosine, that does not equal 1. It equals something crazy, okay? It's only, those are the Pythagorean identities. They have to be squared, all right? All right, a much easier way to work this problem is what I saw somebody do on the board this morning when they were in here practicing. Maybe what Elena was going to say, and yes, you could do that. You could change cotangent to 1 over tangent. And by the way, you don't have enough experience yet, but this isn't going away. You'll do this in here and next year. With experience, you'll start to learn to draw the words tan and secant together in your mind. Even in calculus, they have a lot to do with each other. Sine, cosine, tangent, and secant, cotangent, and cosecant. Anyway, I might would have stayed with the tangent now. And now, this morning when someone just did this, so Daniela, watch how they did it. We just went a different route. That's tangent squared x plus 1, and what's tangent squared plus 1? Done. But I'll grade what you write, okay? All right, let's go to number 6. You kind of can't help yourself, I hope, but change those cosecants and secants when you're on number 6. On number 6, I have sine x. 1 over sine is cosecant, cosine x, and I have 1 over cosine, and then what are you going to do next? Whatever y'all say, keep, change, flip, or whatever. I say multiply by the reciprocal. And so that gives you sine squared x plus cosine squared x, which is 1. I'm not going to do this on this test, but it would be interesting and really fair for an honors class if all of a sudden you got there and had the shocking thing that you're not expecting. What if I said, graph this? Wouldn't you love to know this? Yeah. Y'all see, you go. You'd have to worry about where it's undefined, but it might have some holes in it or something. But y'all see what I mean? That's what we're talking about. Let's go back to number 4 real briefly. After this test, in fact, part of your worksheets that you don't have to worry about, and I'll explain that in just a minute. After this test, we're going to go into this. If you go back to number 4, where you have cosine squared x times secant squared x minus 1, you're going to have equals like a number. You're going to have to solve these. Well, good luck. I mean, start to think of angles that are going to work there. I can't do that. I mean, I guess I could brainstorm for a while and hope I got it all right. But that's where you want to learn what I'm doing, okay? I got to change that into something. So I think after this section, you would think to change secant squared minus 1 into tangent squared. Then that's tangent squared is sine squared over cosine squared. So now I have sine squared equals 1/2. I square root. I get sine x equals plus or minus 1 over root 2, which is plus or minus root 2 over 2. And then I think y'all could start listing me some numbers that would make that work, like 45 degrees. Do y'all see what I mean, though? Like that's why we're doing what we're doing. You've got to be able to morph it into something that you can work with. You're not going to have to solve on the test. We'll start that afterwards. You're just going to have like an expression that you change it into. All right, while I'm doing this page, let's go on and do 7 and 8. I felt like a lot of people clocked through 1 through 6 on their homework when I heard from them and needed more help on 7 and 8. On 7, what can you change 1 minus sine squared into? Cosine squared. And 1 plus tangent squared? Secant squared. And then I can change secant squared into 1 over cosine squared, and I get 1. Here's where you could go in the wrong direction, to be quite honest with you. You should look at identities. I work sometimes on my own sheet of paper if I haven't worked it before. Sometimes you'll see 2 or 3 lines and I'll scratch it out and go, well, that wasn't right, okay? If you foiled that out, you probably got stuck. Okay, I don't know, you might do it, but it would take longer. And then the last one, there's a variety of things you could do here. I'm just gonna do this one. One thing you could do is rewrite it as 2 fractions, like secant squared x minus 1 over secant squared x. That would be 1 minus cosine squared, which is sine squared. I bet some of you changed the top to tangent squared, though, did you?
Yeah.
All right, so that's tangent squared, and then you went the sine and cosine route. I just grade what you do, okay? Flip the page. I'm sorry, that was provided to you. Now turn the page and you're on this. And I think this is the one I provided my solutions to give you more practice. If this is your first page of the packet, this is your first page of the packet. All right, let's double check what I've given you. Oh no, that's not it, is it? That's the one I just did. Darn, I wish I'd known that. All right, I will also post the solutions to this page, okay? But I'm going to do a couple of them with you. So let's go to, I'll post my solutions to this sheet. And I won't ask anything on the test that we have not, like a technique that we haven't done yet, okay? So, I'll be really careful to only do ones. In fact, I may have you mark some out not to practice, just so you know what you should focus on and what you shouldn't. Let's go to number 3. Or I think you're going to be okay on number 2. Let's go to number 3. Number 3 is 1 over tangent beta, or tangent b, plus tangent b. You're supposed to change that into secant squared over tangent. I'm just looking to see if I already have the solutions to this. But anyway. All right. There's a few different routes you could go here. You could start full on sine over cosine. You could change that to cotangent. But also keep an eye on my picture of my jigsaw puzzle box. You see, it's still got the word secant and tangent in it. So I'm thinking I'm going to leave the word tangent in there, okay? So I want to add fractions like Danielle and I did this morning, so I'm going to get a common denominator. Common denominator is tangent. This one already has tangent in it. What will this one become? Tan squared, and you're done, aren't you? What's 1 plus tangent squared? Secant squared over tangent. Done. All right, let's go to number 4. Again, I'm going to work these pretty fast. I post my videos so you can slow me down. Or, as Isabella said, you could speed me up. So, wow. All of that just becomes 2 secant theta, which you even think like how easy that would be to graph or work with or whatever, as opposed to this mess on the left-hand side. All right, it's already in sines and cosines. So I'm kind of thinking I'm going to get a common denominator. I don't see anything else to do. A lot of times that's how you decide. You're like, I don't see any squares. I don't see anything I can do. So I'm going to get a common denominator. I do not multiply the bottom out. Does anybody know why? I'm hoping that something will,
Cancel.
it's not necessary for one thing, and I'm hoping something will cancel. What are you going to have to multiply the first one by? Hang on, girls. What? 1 plus sine theta. Thank you, Danielle. Okay. Doesn't this one need a 1 plus sine theta? Okay. What does this one need? A cosine. So I got a common denominator. Now I'm going to do FOIL. 1 plus sine theta plus sine theta plus sine squared theta plus this lone cosine squared theta over there over this. I bet some of your brains already started firing on that right there. And you're allowed to do what I'm about to do if you don't want to rewrite all that stuff again, but you could, by the time you call me over to your desk and go, is this okay? You probably could have just written it out again in another line. But what is this? 1. So how many ones do you have on the top? 2. How many sines do you have? 2. Okay. I guess it's not me. I guess that's someone else. Any ideas? What can you factor out of the top?
2.
A 2. What does that leave you? 1 plus sine theta cosine theta times 1 plus sine theta. Now what happens? Cancel. And if 1 over cosine is secant, what's 2 over cosine? Okay, so it's technically like this. Wouldn't that be the same thing? You don't have to write that though. This would be 2 secant theta. So the big deal there, you may look up there and go, oh my gosh, it's so ugly. I had 2 fractions. I didn't see any identities staring me in the face like that were normal, like sine squared plus cosine squared. So a lot of really higher level mathematics, which is what you're in right now, is continuing to walk. It's just like when you're in a hard time in your life, people say take one step at a time. So go, I'm going to get a common denominator and see what happens. And it really flows, okay? So, so on 7, I'm thinking I would get a common denominator if you want to write CB next to that. On number 8, you see an identity popping out at you? What's sine squared plus cosine squared? 1. Okay, so look for things like that to make your life easier. And I'll tell you what I'll do. I'll put updated so you know I've done it. So when you look at assignments, if you wonder if I updated yet, it'll say capital updated homework for Friday, okay? And I will post the answers to this one, my solutions. Yours can be different from mine. And then listen carefully, I know you have to go. In the next 2 pages with this grid stuff, I've already posted the solutions to it, or someone's besides mine. If there's some of them I don't want, you don't have to do, I'll X them out. So I'll repost, okay? And you are not responsible for anything after that yet. You're responsible for keeping up with the pattern. So just the first identity page in your